This video is confidence intervals for finding the mean when the population standard deviation is unknown, part 2. So we've been talking about confidence intervals when we don't know the population standard deviation, but we do know the sample standard deviation. So here is the formula that you would use in that case when you don't know the population standard deviation. You're going to do your point estimate, which is x bar, plus or minus the margin of error, and to find the margin of error we multiply the t critical value rather than the z times the sample standard deviation over the square root of n. So we find these numbers, we plug them in, we crunch the numbers, we're done. Example 3, potato chip bag. A potato chip company wants to evaluate the accuracy of its potato chip bag filling machine. Bags are labeled as containing 8 ounces of potato chips. A simple random sample of 12 bags had a mean weight of 8.12 ounces with a sample standard deviation of 0.1 ounce. Construct a 99% confidence interval for the population mean weight of bags of potato chips. So because we know the sample standard deviation, and even if they didn't use the word sample here, you can still tell that it's a sample standard deviation. Look at the full sentence without that word. A simple random sample of 12 bags had a mean weight of 8.12 ounces with a standard deviation of 0.1 ounce. That means that that standard deviation of 0.1 ounce is for this sample of 12 bags, which makes it a sample standard deviation. So because it's a sample standard deviation and not a population standard deviation, we will be using the T formula. So we will be using x bar plus or minus the T critical value times the sample standard deviation over the square root of n. So let's write what we know. We know x bar is the sample mean, which is 8.12. We don't have t yet. What we do know to find t is the degree of freedom is n minus 1, so that would be 40, no, sorry, not 40. It would be 12, because there's 12 bags minus 1, so degree of freedom is 11. And our confidence level is 99%. So we're going to go forwards to our table, and we find our confidence level right here, which is 99%. Then we go to the left hand side of the screen and we find our degree of freedom, which is 11. We go across and see where it meets up. It meets up at 3.106. So let's put that in here. 3.106. Then we need our S, which we saw was 0.1, and our N is 12. Now we're going to fill in the blanks, and we get 8.12 plus or minus 3.106 times 0.1 over the square root of 12. So now we are going to use the calculator. I'm going to do this off screen. 8.12 minus, I always do minus first, 3.106 times 0.1 over the square root of 12, and we get 8.030337503. I'm just going to write 8.030. I'm going to go 3 places because the mean was 2, so I'm going to go out 1 past that. And then I'm going to do it again with a plus sign instead. And this time we get 8.20966. So if I rounded that to 3, that rounds to 210. So 8.03 to 8.210. So here's our confidence interval right there. Remember, we write these in a sentence format to interpret it. So for our sentence, we are 99% confident that the true mean weight of the chip bags is between 8.03 ounces and 8.21 ounces. So what does that mean? So since the chip company, they wanted to evaluate the accuracy. How accurate is the chip bag filling machine? Well, the bags are supposed to contain 8 ounces. Well, look at the confidence interval that is used to estimate the mean. This is saying, well, we don't know the exact mean of the chip bags, but we can tell you that the mean is anywhere between 8.03 to 8.21, which means the fill weight of the chip bags is actually more than 8 ounces, because the lowest the mean could be is 8.03. So the mean fill weight that it's actually filling is over 8 ounces. So they are overfilling the bags. That's what that means. All right. So just like when we did the Z formula for confidence intervals, when we did know the population standard deviation, there was a calculator or function in the calculator that we could use that would allow us to not use the formula and just go straight to finding the confidence interval. Well, the same thing is true here with the T interval. So you're going to get there the same way that we got to the Z interval. You're going to go to stat, then you're going to arrow right to tests, just like we did before. But instead of choosing 7, we're going to choose 8, T interval. And we choose T interval when we are estimating the confidence interval for a mean and we don't know the population standard deviation, but we do know the sample standard deviation. So I've gone back to the potato chip bag example, and I want to pull the calculator up, and we're going to see if we get the same thing with the calculator. So we go to stat, we choose tests, and you're going to go down to number 8, T interval. Again, we're choosing this because the standard deviation they gave us was the sample standard deviation. So you can either hit the number 8 or you can scroll down to 8 and hit enter. They've given us the statistics, so we choose stat. Our X bar was 8.12. Our SX, that's your sample standard deviation, that's 0.1. Number, that is your sample size. And it just disappeared. Okay, got it back. The sample size was 12, and the confidence level is 0.99. Go to calculate, and look what we got, 8.03 to 8.2097, which rounds to 8.210, just like we got right here. So there you go. So let's look at example 4. Example 4 says a random sample of 45 Hollywood movies made since the year 2000 had a mean length of 111.7 minutes with a standard deviation of 13.8 minutes. Construct a 92% confidence interval for the population mean. So anytime that you're doing a confidence interval for a population mean, check your standard deviation and figure out which kind of standard deviation did they give us. So here's our standard deviation is 13.8 minutes. It doesn't say which type it is. It just says with a standard deviation. So we need to go look at the context clues here. Read the sentence that it's in. A random sample of 45 Hollywood movies made since the year 2000 had a mean length of 111.7 minutes with a standard deviation of 13.8 minutes. So, is this standard deviation for this sample of 45 Hollywood movies? Yes, it is. So that means this is a sample standard deviation, and you're either going to use this formula or you are going to use the calculator and choose t interval, one or the other. So I'm going to fill in the formula here. So x bar is 111.7. Our critical value, it wasn't on the chart. 92% wasn't on the chart, so I had to do INVT. So 92% is in the middle, 4% on either side, because together it makes 1. So we want this number for the critical value right here. INVT 0.04. Degree of freedom 44. You get 1.792. Now I realize some of you do not have that capability on your calculator, and that's okay. I'm not going to give you a test question that has a critical value that is not on the table. Anyway, so on back to the formula. Times S 13.8 over square root of n, square root of 45. And we get 108.01 to 115.39. We can write it in a sentence. We are 92% confident that the true mean length of Hollywood movies is between 108.01 minutes and 115.39 minutes. So let's check it with a calculator. We're going to get a stat, test, choose number 8, t interval. Our mean is 111.7. Our standard deviation is 13.8. Our sample size n is 45. Confidence level is 0.92. And we get 108.01 to 115.39. Same thing. Okay, check out this one, example 5, cereal box weights. Boxes of cereal are labeled as containing 14 ounces. Following are the weights in ounces of a sample of 12 boxes. It is reasonable to assume that the population is approximately normal. Here's the weights. Construct a 95% confidence interval. Based on this confidence interval, are the boxes labeled correctly? So first, they don't give us a standard deviation, but because I have this sample data, I could find a sample standard deviation if I needed to. So the first thing you're going to do is go to Stat and Enter and put the data into one of your lists. So here I've put the data in to L1. So now I'm going to go ahead and I'm not going to use the formula. I'm going to go straight calculator. I'm going to go Stat, Test, number 8, because I don't know the population standard deviation. I don't know the statistics, but I do know the data. So choose data this time and hit enter. It's going to say, which list is your data in? So tell it which list. Mine is in L1. Frequency should stay 1. The only thing you need to change, other than your list, if need be, is your confidence level. So 0.95, calculate, and I get 14.026 to 14.104. So we've written it out here. If you wrote a sentence, you'd say we are 95% confident that the true mean weight of the cereal boxes is between 14.026 and 14.104 ounces. So based on this confidence interval, are the boxes labeled correctly? No. This whole thing is above 14. 14 does not fall within this interval, so the true mean is not 14. So are they labeled correctly? No. They're definitely overfilling them. So pause the video quickly, read through this example, try it on your calculator, then hit unpause, and I will have the answer written on the screen. Okay, if you chose T interval, because again, they're giving us a sample standard deviation, the average score was 5.53 with a standard deviation of 0.92 for the sample of 263 students. So we did a T interval. We got 5.43 to 5.63, so we are 99% confident the true population mean score is between 5.43 and 5.63. And I believe that is all for this section. Hooray! So let me know if you have any questions.